to work. Alright? And I think we've heard on Footloose, and the whole objective of me having that little skit for you on Footloose is to make sure you get to feel a little bit relaxed so that maths comes to you very easily. I don't want you to be a nerd, alright? I just want you to stay focused in education, find the beauty of maths. And I said to you, Maths with Kumar will be fun, and in every video clip you will see something different. But I can assure you that you're going to learn your maths really well, and you're going to be A's. Follow what I do. Give you the sums, do them. Work hard, shall we? And play hard. Give me a 5. That's your hand. Yeah! Alright, let's look at this. Rate of change, practice drill. Okay, as I said to you, I'm not wanting you to do 20, 30 sums. Just let's do 5 sums, good sums, and master it. Now, the earlier techniques that we did on rate of change, ooh la la, beautiful sum. Remember at Greenwich, what the father did? Followed the daughter in the car, the chase. Look at those sums and a few other sums that we did. 3 beautiful sums. They were really challenges, isn't it? Okay, look at it, revise it, and now the next drill, and you would go with ease. Now we look at this sum. This is a graph. Alright, it's a speed time graph, meters per second, time, seconds. Now for the first 5 seconds, the speed of the ball, the word the is missing, alright? The speed of the ball is given by this formula. V equals to 5 plus 3t. From the given graph, find VO, yes, that's VO, and V1, you're asked to find. And the distance covered in the first 5 seconds. What is the distance? And then the average speed. Are you struggling? Not at all, right, my dear? Because you've got it. Yeah. What is it like? Who controls this equation? Speed, like how when you're driving, the driver controls the speed of the car. Who controls in this sum? This is very powerful information. V equals to 5 plus 3t. So if you look at the sum, V equals to 5 plus 3t. When it is VO, when you look at VO, that means the time here is 0 seconds. So when the time is 0, what will be the speed? So you'll be 5 plus 3 times 0. So that speed is 5 meters per second. Got it? Great. Next, what is V1? V1, you look at the time again, it is 5. Alright, you put 5 into the equation and you get V equals to 5 plus 3 times 5. Okay, 3 times 5. What do you get? You get 5 plus 15. 5 plus 15 will be 20. So that is V1, 20 meters per second. Got it? Good. Now, let's look at this again from there. What happens after that? Okay, from 5 to 12 seconds, the speed here is constant. The 5. So this equation is for the first 5 seconds, alright? That's the speed that's given. And we're now going to look at it from the given graph. You're asked to find VO and V1. And what is the distance? So we've got these 2 parts done. And what is the distance covered in the first 5 seconds? Now we know, my dear, is the area under the graph. This area. And what is this measurement that's given? VO is 5. And what is this part given? V1 is 20. So if you look at it very carefully, we've got to find this area. This length here is 20, this is 5, and this is 5. So the distance under the graph will be, alright, you find distance, 5 plus 20 divided by 2 times 5. That is the formula for the area of trapezium. Got it? So you got 25 plus over 2. You've got 25 over 2 times 5, which is 125 over 2. And that will give you a distance of 62.5 meters. That's the distance covered. And when you want to find the average speed will be the total distance over the total time. Now if you look at it, my dear, okay, the total distance here from 5 to 12, this is 7. And from here to here, it is 20. So what will be the total distance? The average speed is equal to total distance over total time. And the total distance will be the area of the trapezium, which is 7 plus 20. 7 plus 20 divided by 2 multiplied by the maximum speed that you reach. So what you get is this whole thing, cancel here, you get a 10. Okay, that's the total. What I'm working out here is the total distance. Alright, and we've got 27 times 10 is 270 meters covered. Got it? Average speed, total distance over total time. And that's 7. And that's 20. So 20, wait a minute, I've made a little error. Because you know why? This is a trapezium. We have to look at it. I've overlooked a very important point. I've taken this to be a trapezium. Look at the diagram, my dear. It is not a trapezium 1. Look at that. That's not a trapezium. The trapezium will be here. Alright? This will be the trapezium. Look at that. This will be a trapezium. Well, the blue one, that is another trapezium. So if you want to find total distance, I'm afraid we can't start from here. I like this error that I made because we learn together. Sometimes, in my case, I was blind. Hey, let me rub my eyes, Kumar. All right. So you see, so this cannot. The total distance covered will be trapezium 1 plus trapezium 2. So you've got this distance here, 5 plus 20 divided by 2 times 5. That's the first 5 seconds that we've got. The distance is here. And then now we've got to find this distance here. This is 7. From here to here is 15. So the area here, let me work out here, will be 7 plus 15, yeah, divided by 2 times 20. Alright, so when you cancel here, you get a 10. 7 plus 15 is 22. 22 times 10 is 220 meters. That's covered. So you have 220 meters here. And so the total distance, my sincere apologies about this error. It was not done deliberately, no doubt, but it has a good learning point. Alright, so it will be actually 62.5, the first trapezium, plus 220 meters. That will give you 282.5 meters. That's the way to do it. If you do not wish to do that way, what you could do is you could draw a line like that and find one, but I'll be very frank with you, that would not be so sensible to do this way. If you draw a line here, and we don't know how we're going to go about that because we don't know this distance, we don't know. But any other ways to do it? I would say this will be the best to find the area. Okay, trapezium 1, trapezium 2. Once you've got that, the average speed will be, can you tell me? The average speed will be equals the total distance, which is 282.5 divided by the total time, 20. So when you divide it by 2, what do you get here? You get 114 1, 4, 1, 2. We get 1, 4, 1. This is 2, 5. Alright, meters per second. That's the average speed. 14.125. Now just want to counter check with your calculator, everybody. Alright, I know you know it, and I told you we should not be computer or calculator freaks, okay? And get your answer right. That's it. 14.125 meters per second. Alright, let's go through the sum again. The first sum for this maths drill. What is so unique? For the first 5 seconds, the ball is moving with this speed. So we could find the speed for the first 5 seconds. This equation does not go through for the whole sum, my dear. Because if I put 12, I would get entirely different. I don't get 20 for the speed. Because if I put here 12, 36 plus 5 is 41. Alright, so that will be wrong. That's why the formula is only for the first 5 seconds. And what is the speed when it's V0? V0 means the time is 0, and V1 t is 5. It still qualifies for the formula. We substitute in and we've got these answers into the formula. The second part is the distance covered in the first 5 seconds. So you know it's a trapezium. And this is 5, 20, add them up, divided by 2, and multiply this distance. This is the height of that trapezium. Got it? So we've got the distance here. Alright? And then the average speed. Okay? So the average speed calls for total distance over total time. And the total distance, let's be more observant. Alright? I was just a little bit careless earlier on. Okay, so you look at it and it said, hey, trapezium. Do not get carried away. Look at the figure again. That's a trapezium. Yep, that's another trapezium. But this figure is not, because it's cutting from here. Unless it cuts from here, then you get a trapezium. So you find this trapezium, add them up, total distance, divide by the total time, that's 20 seconds, and we've got the speed of the sum. Good. Okay? Right. Let's go to the second sum before you have a small little 1-minute break. Let's look at what this sum is all about. Yeah, question 2. Hey, look at that. There's no units of measurement here at all. Ooh, what is it all about? They say the graph above shows the speed time. Given that the total distance traveled in X seconds is 1 kilometer, calculate the maximum speed in meters per second given that the distance traveled in the first 35 seconds is 700 meters. And then you have to find the value of X. Like here, it's a little bit different. It calls for thinking. What is it? Now they said in the first 35 seconds, the distance traveled is 700 meters. And then the total distance covered is 1 kilometer. So they want to find the value of X. Now that makes it a lot more easier. We say, hey your distance here is 700 meters. And you take 35 seconds. And what is this line from here to here? 15. And this is 35. 35 take away 15 is 20. So we want to put this height here as h. Alright, that's the height h. So we want to find the area. We know the area of this trapezium, which is 20 plus 35 divided by 2 times h is equal to 700. Okay, we've got a 55 here. 55h. Bring the 2 up. You get 1400, and so your height is going to be 1400 divided by 55. Alright, when you divide by 5, we get 11 here. Here's a 2. Carry the 4, you get 280. So far, okay? Divide by 5, you get a 2. carry the 4 up, 40 is a 5, and that's what you get. So your height will be 22, and you carry the 6 up here, you get a 5 is a 55, and 5 over 11. So this point here is 25 and 5 over 11. 25 holes and 5 over 11 meters per second. That's the maximum speed. So they said, hey, what's the maximum speed? So therefore, the maximum speed, look at it, the maximum speed is equal to 25 holes, 5 over 11 meters per second. You got it, my dear? How did we do it? We know that the area under the speed time is equal to distance covered. And we are given that this distance is 700. Okay? And the perpendicular height here is the speed. And so happened to be the height of this trapezium. That same height here and that same height here. So using a trapezium formula, we found out what is h. Now they want to find the value of x. Now what about x? We were given this part, the sum. 1 kilometer is traveled in x seconds. That means this whole trapezium is taking, the whole distance is 1 kilometer. And we know the length here is 20, and we know here right up to here is x. So if we look at part 2, the distance is going to be b1 plus b2 divided by 2 times the height. It's a trapezium, and the distance covered is 1,000 meters, all right, which is 1 km, and we could work that out. And this is 20, all right, and this whole length here is plus x divided by 2 times the maximum height here, the height here, the perpendicular height, okay, which is your h. And your h is given here, 280 over 11. Or you can say the improper, that's the improper fraction, this is the mixed number. Alright, so I will take the 280 over 11. And now let's look at it, my dear. We said, open this up, 2 times 11. Just a simple algebra. Okay, we're going to solve this. 2 times 11 is 22. This is 1,000. Bring the 22 up, 1,000 times 22. And bring the 280 down. And this whole thing is 20 plus x. Work it out, my dear. You can cancel this off. Yep. And, well, use your calculator because you just need to some accurate results. 100 times 22. Okay? As I said to you, only use calculator when you need things and it's not necessary to go all the way. So if you look at it, that's 550 over 7. Aha! This whole thing is 78.57 minus your 20 is giving your x. So your x will be about 78 minus 20 is 58.57. If you round up, it's about 59 seconds. Got it? Great. Therefore, x is equal to 59 seconds when rounded up to the nearest whole number. Look at the sum and see what they want. If they want to the first decimal place, you can put it as 58.8 seconds. If they wanted to round up to the nearest whole number, then do so. As long as above 5 and above, add 1. Alright? So the sum. Look at number 2 again. You've got this lovely graph here. They tell you that the total distance covered is 1 kilometer. And this is in meters per second. This is in seconds. So be very, very, aha, what are you? 1 kilometer your 1,000 meters. Get your measurement. That's the area under this graph. And then apply the concept of your trapezium. Okay? So you put 20 plus x divided by 2 times this height equal to 1,000. And then you solve for x in a systematic way. Now, my dear, we'll come to more sums, applications on distance, time, and how a little bit of difference in different sums. And I'm sure you become an expert. 3 more sums, and you are done with speed time. I'll catch you.